Good morning, one and all. So today we are going to discuss about counters in sequential circuits. So this is another one video from myself, Binesh Sarunesan, working as an assistant professor in Rohini College of Engineering Technology, Kanyakumari. So counters are classified into two broad categories. Okay, one is asynchronous counter and another one is synchronous counter. So two categories are there. One is asynchronous counter and the second one is synchronous counter. So this is the basic difference between synchronous counter and asynchronous counter. So all the flip-flops are clocked simultaneously. Okay, all the flip-flops are clocked simultaneously in asynchronous counter, but in synchronous counter all the flip-flops are clocked simultaneously. Okay, asynchronous flip-flops, the flip-flops are not clocked simultaneously. Not clocked simultaneously, but in synchronous counter all the flip-flops are clocked simultaneously. Then the second difference is the delay time of all flip-flops are added. Therefore there is considerable propagation delay. That is, the operation time is large in asynchronous counter, but in synchronous counter the propagation delay is very small. Then speed of operation is low for asynchronous counter and speed of operation is high for synchronous counter. The logic circuit is very simple. The design of asynchronous circuit is very simple, but synchronous counter is somewhat complex in design. Okay, so these are the main difference between synchronous and asynchronous counters. So first we are going to discuss about 2-bit synchronous counter. So 2-bit synchronous counter means it will count 4 sequences. Okay, 2-bit. Okay, only 2 bits are there. So 2-bit means 2 power 2. So it will count 4 sequences. The sequences are 0 0, 0 1, 1 0 and 1 1. Okay, the sequences are 0 0, 0 1, 1 0 and 1 1. So the design is very simple. See here, only we are using 2 JK flip-flops. Okay, only we are using 2 JK flip-flops. The input is always 1. Okay, the JK inputs are always 1 for the first flip-flop. JK input is always 1 for the first flip-flop. So initially assume that all the values are 0. Okay, initially assume all the values are 0. Like this. Okay, so 0, so give is 1. Sorry. Now see, we are giving a input 1. Okay, we are giving a input 1. So while giving 1 1, the output will be complemented. While giving for 1 1, the output will be complemented. The Q0 becomes 1. Okay, Q0 becomes 1. So similarly, here the input will go as 0. Okay, this 0 will go here. So 0. And here also 0. So 0 0 means no change. So next output is 0 1. Okay, like this. Q1 Q0. Okay, Q1 Q0, because this is MSB. Q1 is MSB and Q0 is LSB. Okay, Q0 is LSB. So we will get the output as first initially this is 0 0. Now it becomes 0 1. Q1 is 0 and Q0 is 1. Okay. Now again the input is 1 1. Now the previous output is 0 1. Okay, the previous output is 1. So now it will be complemented. So Q0 becomes 0. Q0 becomes 0. Now here the input is 1. Okay, so both the inputs are 1. So now this 1 will go here and 1 1. Input is 1 1. So the previous output is complemented. So this will become 1. So similarly the next output will be 1 1. Okay, the next output will be 1 1. Then after 1 1 it will again count 0 0. So this operation will be rotated. This is the operation of a simple 2-bit synchronous binary counter. Okay. So this is a timing diagram. So in each and every counter design you have to draw this timing diagram. That is must. Okay. So here for the first clock pulse, first initially the input is 0 0. Then after the first clock pulse, Q1 becomes Q1 again 0 and Q0 goes to 1. Okay, then 1 0, then 1 1, then finally 0 0. So this is the timing diagram of 2-bit synchronous counter. Then for 3-bit synchronous counter, there is only one difference, that is after the second stage. Okay, after this second stage, you have to put an AND gate, and the input for this AND gate is Q0 output and Q1 output. Input of this AND gate is Q0 output and Q1 output. Then this ANDed operation output is given as an input to J2 and K2. Given as an input to J2 and K2. So the operation is very simple, like the previous one. So this input is always 1, jk input is always 1. So it will process, initially the value will be 0 0 0. Okay, 0 0 0 means this is q2. Okay, q2, q1, and this one is q0. So after the first clock pulse, q0 becomes 1, and if these two are in no change condition, then it will become 0 1 0, then 0 1 1, then 1 0 0. After that 1 0 1, then 1 1 0, then 1 1 1. Finally after 1 1 1, again it will be goes to 0 0 0, reach the condition. Okay, so this is the operation of a 3-bit synchronous counter. The only difference is in the diagram, after this second stage you have to put another one AND gate here. Okay, if it is a 4-bit counter means, so after this one, after this Q1, after this flip flop, okay, now this Q1 J2 flip flop, this is Q2 actually. So after this J2 flip flop, you got to put another one AND gate. This AND gate out input is from here. These two outputs will be ANDed. Okay, so again here the flip flop will come like this. So this is the timing diagram of this 3-bit synchronous counter. Thank you for watching.